Hello everyone. Today I will be talking about managing states in ReactJS, a crucial concept for building dynamic user interfaces. This presentation will cover the basics of state, its use in both functional and class components, best practices, and some advanced state management techniques. What is ReactJS? ReactJS is an open source JavaScript library developed by Facebook used to build user interfaces. It enables the creation of dynamic UIs with reusable components. What is states? State in React refers to data that can change over time and influence how components render. Unlike props, which are passed down from parent to child components, state is local and mutable. States hold data that can change over time, and this data directly impacts the component's rendering. For example, in a counter component, the count is stored in state and the UI updates whenever the state changes. Next, we shall talk about the features of state. There are three major features: encapsulated, mutable, and reactive. State is local to the component it belongs to, meaning only that component can modify its own state. If needed, it can be passed on to the child as props, but it's generally controlled by the component itself. Mutable. State is mutable, meaning you can modify it over time. In class components, we use this set state to update state, while in functional components, we use useState hook. Reactive. State is reactive, meaning when the state changes, React automatically re-renders the component, ensuring that the UI is updated with the latest state. Here, we have an example of a counter app. In this example, we are creating a simple counter app with increment and decrement functionality using React's useState. The component counter app manages the count state, which starts at 0. We have two buttons, one to decrease the count and the other to increase it. Let's have a code breakdown. The first line has const count set count equal to u state 0. Here we define the count state and the set count function using u state hook. The initial value of count is set to 0. The first button, when clicked, triggers the set count plus 1 function, which increments the value of count by 1, whereas the second button, when clicked, triggers the set count minus 1 function and decrements it by 1. The result is displayed in the h2 tag, which dynamically updates based on the current value of count. Next, we shall know the differences between props and states. In React, both props and state are used to handle data, but they have distinct differences in how they function within the application. Props are used to pass down data from the parent component to a child component, while state is used to store data within the component. State is managed within the component itself, which means that the component has control over its own data, whereas props, on the other hand, are passed from the parent to a child components, meaning that once they are set by the parents, the data is set by the parents, they cannot be modified or mutable by the child component, making props immutable. And state is used for data that can be changed and affects the behavior of the components based on the rendering whereas props are typically data which are passed on from parent to the child, which is based on the requirement and the necessity of data. Next, we shall know state and functional components. In React, functional components traditionally did not have state management capabilities until the very latest versions of React and have gained the ability to manage state through useStateHook. The useStateHook is the simplest and the most common way to introduce state into a functional component. The syntax const state set state equal to use state initial value is the syntax. So here we have three things: state, set state, and initial value. State is the current state value which can be of any data type: number, string, array, object. Set state is the function used to update the state, and initial value the starting value of the state. So here, okay, now let's see the state update process. When an event happens, let's say a button click, the state is updating using a set state function. Once the state changes, React will automatically trigger a re-render of the component. This re-render ensures that the UI is updated to reflect the new set state value. Here you can see that the set color function. So let's assume we have a set color function. So on clicking of a new color function, the state of the page of the DOM changes. State in class component. In React class component, state is an object that stores dynamic data and controls the component's behavior and rendering. The key points of state in class components is mutable, triggers re-renders, initialization, and updating state. Unlike props, which are immutable, states can be changed within the component. This gives components the ability to dynamically adjust to the user's interaction. Second, triggers re-renders. Whenever state changes, React automatically re-renders the component to reflect the updated data. This is a core mechanism that makes React UIs interactive. Initialization. State is typically initialized inside the constructor method, which is called when the component is created. Updating state. To update the state in a class component, we use this set state method. This method not only updates the state but also triggers a re-render of the component to reflect the changes. Let's take a look at an example of how state is used in a class component. We have a timer component that increments a seconds counter every second. The timer component starts at the seconds set state set to 0. Every second, the tick function updates the state and triggers a re-render. The component did mount method sets the timer in motion by calling set interval, while component will unmount stops the timer once the component is no longer in use. Each phase of the life cycle here shown allows developers to hook into a process, control the component's behavior. For example, in the component did mount method, we can start a timer, and in component will unmount method, we can clean up or clear the timer. Whereas in the middle, the updating happens. In React class components, the component life cycle refers to the series of events or phases that occur from the moment the component is created to when it is removed from the DOM. Now, what is DOM? DOM is Document Object Model, which is a programming interface for web documents. Now, let's talk about some of the best practices for managing state in React to keep your code efficient and maintainable. First is minimize state. First, minimize the amount of states you use. Only store data that directly affects the UI or component behavior. For instance, avoid storing values like area if you already have length and width as state variables. You know, just compute the area of the slide. Next, it is a good practice to use derived states. Instead of storing values that can be calculated from existing state, calculate them as needed. This helps you to reduce redundant data and keeps your state more efficient. Next, another important tip is to avoid state duplication. Do not store the same data in multiple places within your components. This can lead to inconsistencies and make it harder to manage state, so keep it centralized. Finally, when updating state based on its previous value, you always use functional updates. This ensures you're working with the latest state. For example, instead of directly modifying state, use set state previous state is equal to updated state to ensure React has the most up to date information. By following these practices, we can keep our React apps clean, efficient, and scalable. Now, let's explore some advanced state management patterns in React that provide a greater control, flexibility, and reusability. These advanced patterns in React give developers a range of tools to create more flexible, reusable, and maintainable components. However, each comes with its own trade-offs in terms of complexity and control. First, component compound components pattern. In this pattern, we create customizable components that avoid the problem of prop drilling, where props are passed down through many levels of components. The compound pattern reduces API complexity and allows for more flexible markup. However, it can lead to too much flexibility, which might increase the complexity of JSX. Next, we have control props pattern. This pattern relies on external state to control the behavior of the component. The parent component holds the state and the child component receives props to control its behavior. This also increases the complexity of JSX and handlers, making the code hard to maintain. Next, we have custom hook pattern. With custom hooks, you can extract stateful logics from components and reuse it in multiple places. This allows for a greater control over state logic while keeping your components clean. However, this pattern can increase the complexity of implementation. Next, we have props getters pattern. Prop getters are used to simplify integration with other components. They allow for flexible and dynamic passing of props to child components, which can be useful in certain advanced use cases. Pros is it simplifies usage and provides flexible props, whereas the downside is that it can obscure the internal logic of components, making it hard to understand. State reducer pattern. This pattern provides full control over the internal state using a reducer. It is often used in situations where the component's internal states needs to be modified in complex ways. It gives you complete control over actions and state transitions. However, implementing a state reducer can be very complex and requires a deep understanding of React and reducers. To conclude, mastering state management empowers you to build a more efficient and scalable React application because state is crucial for creating dynamic interactive UIs, enabling components to react to the changes in data, and managing states effectively in both functional and class component is a key to controlling app behavior and rendering. So, following best practices ensures efficient state management and helps avoiding common pitfalls like unnecessary re-renders. And we can also use patterns to improve the scalability and maintainability in complex application. Thank you.